In this video, I want to look at factoring functions that are quadratic in form. So these are going to be functions that really look like quadratic functions if you make some substitutions, but initially they won't be as you'd seen before. So here's a question. It says find the zeros of f of x equals 2 times x plus 1 squared minus 5x plus 1 minus 3. So if you look at that, you might say and see immediately that if you were to multiply this all out, you would certainly get a quadratic equation. But you might look and see that this has the form of a quadratic equation. What I mean by that is if you look at this term right here, which is being squared in this case, it's x plus 1. You see that here's a term here to the first power. And so if you were to make a substitution, let's say let u equal x plus 1, then of course u squared would be the quantity x plus 1 all squared. And then you could substitute that in, and then you would then have a function of u, of course, that was equal to 2u squared minus 5u minus 3. And you could do whatever you wanted to with this new quadratic function of u. And just remember at the very end that you'd have to go back and replace all the u's with x plus 1s, and then you could finish your problem. So I've simplified this greatly by writing it like this, because I can certainly now factor this quadratic trinomial. So let's go to another sheet here and get this factored and see where we can go. So I think here's the piece I want to bring over. So we're in good shape now. So I'm going to say, remember we in our previous video said what we want to do is take the coefficient of the square term, which we call a, and c, and multiply them together. In this case we get minus 6. And now we're looking for the factors of minus 6 that add up to be minus 5. So the factors of minus 6 that add up to be minus 5, I believe those might be something like minus 6 times 1. I'll just check that, and it is the case that minus 6 plus 1 does equal minus 5. So those are the two factors I want to work with this time. And so I'm going to rewrite my quadratic function as 2u squared, because I want 4 terms here, because I want to be able to factor by grouping. And then that's going to be minus 6u plus u minus 3. And so I'm just going to double check here. Minus 6u plus u does equal to minus 5u, so I've got that set up correctly. Okay, so I'm going to group the first two and group the last two because I think they've got common factors in the first two there. So I have 2u squared minus 6u grouped together plus u minus 3. In the first two terms here, I have a common 2 and a u. So I'm going to factor out the 2u, and I'm going to be left with in there u minus 3 plus, just for emphasis, that's 1 times u minus 3. All right. So I'm well on my way here. I'm going to get this over to another sheet so I have some more space. Copy that, paste it over here. Alright, so now in these two factors, what do I see here? Well, I've got a common u minus 3 in each of the terms, right? There's a u minus 3 there, there's a u minus 3 there. So let me factor out that u minus 3 carefully and see what's left. So when I factor u minus 3 out of the first term, I'm left with 2u. When I factor it out of the second term, I'm left with plus 1. And just be careful, because often students forget that there is a 1 that's there, and it's not often written, but I put it there for emphasis so we can see it this time. So I have u minus 3 times 2u plus 1. And remember, the whole problem was that we wanted to do what? We wanted to find the zeros, right? So in order to find the zeros, we ultimately do our factoring, and then we set that quadratic function equal to 0. So I'm going to do that. And so each of these factors get set equal to 0. So I have u minus 3 equals 0. And I've got 2u plus 1 equals 0. if you carefully solve for those, you're going to get that u is equal to 3. And then over here, I believe you're going to get u is equal to minus 1/2. Right? Because 2 times minus 1/2 would be minus 1, and minus 1 plus 1 is 0. Now, I've got the zeros for this function of u, but remember, I wasn't looking for the zeros of the function of u. I made a substitution to simplify this for me. And my substitution, you all just have to remember that my substitution was u was equal to x plus 1. So I found now that in one of my cases, u was equal to, the first case there was 3. So when u is equal to 3, I need to find out what x is, because that's really the problem I was trying to solve. So then I get that 3 is equal to x plus 1. I'm going to subtract 1 from both sides, and I get that x is equal to 3 minus 1, which is 2. So I like to write it like this. X is equal to 2, right? So there's one of my zeros. And then I'm just going to go back here so I can recall what do we have here. U is equal to minus 1/2. So let's go ahead and do that one. So I've got minus 1/2 is equal to x plus 1. I'm going to add 1 to both sides. Let's see, when I add 1 to minus 1/2, I get I get plus 1/2, right? 1 minus 1/2 is plus 1/2. Oh, I think I made a mistake here, because I'm supposed to be actually subtracting 1, right? Subtracting 1. So let's see if we can get this straight. So I'm actually subtracting 1 from both sides. So on the right-hand side there, I'm going to get x. And on the left-hand side, I get minus 1 minus 1/2, so that's going to be minus 3/2. And again, I like to write this in the order we normally do. So x is equal to minus 3/2. And now I found the zeros for my original quadratic function, and I just did a quick substitution in order to turn it into something that's quadratic in form.